For the last bit of Chapter 3, we're going to introduce acids and talk a little bit about their nomenclature. An acid, so this is going to be the definition that we're going to use. So it's any compound that will produce hydrogen ions if it is placed in water. This is a hydrogen ion, H+. Now, acids are covalent compounds. So they have, their atoms are bonded with covalent bonds. But we can think of them as a hydrogen ion that is attached to an anion. And that anion can be a single atom or a polyatomic ion. It can also be a simple anion or an oxoanion. A lot of them are oxoanions. Remember from the previous slide or the previous video that oxoanions contain oxygen, whereas simple anions do not. So if I have a simple acid with so it's not an oxoanion, it doesn't have any oxygen, we remove the gen ending from hydrogen, just leaving the hydro, and then we change the IDE ending to ic. Then we combine the words and add the acid, the word acid at the end. Here's some common acids that do not contain any oxygen, so they're not oxo anions. So for example, HF, we drop the hydrogen. Fluoride is the compound name that we would name from a covalent compound. Then we take the hydrogen, we drop the gen, so we have only hydro, and then from fluoride, we drop the IDE and we add the ic. So hydrofluoric and then acid. This is hydrochloric acid, hydrobromic acid, hydroiodic acid, hydrocyanic acid, etc., and hydrosulfuric acid. So this is how we name acids that do not contain any oxygens. Once again, you can print this and have it handy, but it would be nice just to remember what the rules are for those acids that do not have oxygen, how we name them. Those acids that do contain oxygen are called oxoacids, and they are derived from the oxoanions that they contain. So here's the rule. If the oxoanion's name ends in ate, then we change from the ate ending to the ic, and we add acid. So you would look at the polyatomic ion table. You find that ClO3 is the chlorate ion. So we drop the ate when we name the acid and we add ic, becomes chloric acid. Instead of chlorate, chloric acid. When it ends in ite, we drop the ite and we add us. So ClO2 in the polyatomic ion list is the chlorite anion. We drop the ite and we add us. So it becomes chlorous acid. When the oxoanion's name has a prefix, we do not drop the name of the prefix that is at the beginning of the oxoanion's name. We retain it when we name the acid. For example, this one, so it's ClO4, this anion in the polyatomic ion list is the perchlorate ion. It ends in ate, so we drop the ate, we add the ic, but it becomes, note that we keep the per in front of the name of the acid. So perchloric acid. These are the rules on how we name acids that contain oxoanions or oxoacids. Here's a sample problem for you to try. There are 3 different acids, so try and name them. Look up what the polyatomic ion, if they have a polyatomic ion, if they have an oxoanion, how does that ending change from the oxoanion name? Or if they don't, like this one, then follow the rules from the table in slide number 2.